Hello, welcome back to Flipped. Today we are on electrolysis. We'll be talking about the rules of selective discharge. Let's unpack the words here, selective and discharge. Selective means we have to choose, out of a range of stuff to choose from, we have to be selective. So we just choose one out of the many things. Discharge, in this chapter refers to oxidation and reduction. So we'll be selective. We'll choose one of the many things to oxidize and to reduce. That's the definition of selective discharge in this chapter. Because we learned in our previous videos that a molten state, for example NaCl, it becomes Na liquid plus a Cl minus liquid. So this one has no problem because there's only one of each charge to choose from. For the positive charge, I just choose NaL, whereas for the negative charge, I just choose Cl minus. That will be all for molten. But in the case of aqueous electrolyte, that is when I dissolve my ionic compound in water to form aqueous electrolyte, there are now H pluses and OH minus as well, because water undergoes ionization as well. What do I mean? In the case I use back of NaCl, so I have NaCl here, solid. When I dissolve them, it's different from molten already. It will form actually Na plus aqueous with Cl minus aqueous. Hopefully this makes sense because now I'm dissolving in water and not melting them. Melting will form liquid, dissolving will form aqueous. So this is pretty similar to molten, but now because I have water in it, because it's dissolved in water, this water also undergoes ionization, which means my water, liquid, will also form H plus aqueous plus OH minus aqueous. So you can see that for each charge now, there's a bit of complication because, for example, the plus charges, I have two to choose from. Minus charges, I have two to choose from as well. So you can see that there are more than one species of cation and anion now. Cation are positive ions, and anions are negative ions. So only one cation and one anion will be selected, and preferentially discharged, which means to be oxidize or reduce. So back to this example, we can see that for the plus charges, there are two to choose from. The minus charges, there are two to choose from. So which one do I choose to oxidize and reduce is very important. And that's why we have rules governing it. Let's start with how to choose for cations. So cations, how we choose is based on the reactivity series. This table is based on chapter 9, metals. When you reach chapter 9, you will be able to find this more familiar. For those of you that are starting with this chapter and haven't touched on chapter 9 yet, let me just give you a brief introduction. So these are how metals are classified. Potassium, sodium, etc. All the way to gold metal. And potassium being the most reactive and gold being the least reactive. And the reactivity decreases down this table, down this series. How to remember this series? We have come up with a mnemonic. It's called Please Stop Calling Me a Colored Zebra. I think leaders have cool silver glasses. So based on this, the first letter corresponds with the first letter of the element. For example, P for potassium, S for sodium, C for calcium, etc. And please note that this is the first letter of the English spelling, because we know that element symbol for potassium is actually K, whereas this one is P. So please take note that please stop calling me this mnemonic, It's used in the English way of writing the element and not its chemical way, Because, for example, potassium is K, sodium is Na, etc. So there's a bit of confusion. Please note that it's an English way of writing. Anyway, back to this. So we learned in chapter 9 that this is reactivity series, We learned the first part, more reactive, all the way to less reactive. But now, in the case of electrolysis, we have to flip it around. Basically, whatever is on top that's more reactive is now harder to discharge. Means it's harder to be reduced. For example, K plus electron to give me K metal. This is way harder than if I were to do, for example, copper. Cu2 plus 2 electron to give me copper solid. This one is very tough to achieve. This one is super easy. Okay, that's the difference. When it's more reactive, it's harder to discharge. In this case, discharge for cation means reduction. Okay, and whereas for the bottom field, it's easier to discharge, which is also a reduction. Okay, so this is the example. I've given you one here. Let me give you another one. If H plus is present, okay, because we see that hydrogen is here, so I written these two stars here because these two are not metals, but they just fit into this reactivity series based on how reactive they are compared to other substances here. So if H plus is present, this is H plus, only copper, silver, and gold can be preferentially discharged, i.e. undergo electrolysis. So what it's saying is that if I have H plus and Cu2 plus, I will choose Cu2 plus. That's what it's trying to say. Okay, and Cu2 plus will undergo this reaction here. Cu2 plus 2 electron to give us Cu solid. This is reduction. Okay, so please recall that there's a way to remember this. It's called ORAC, O-R-A-C. Okay, oxidation always happens at anode. Reduction always happens at cathode. Okay, this one, cations, is always at cathode, and that's why it's always reduction. Okay, hopefully this is clear. So now we have understand how cations undergo, how cations are discharged based on the reactivity series. Whereas for anions, they are a bit different. They are based on concentration. Okay, so we talk about cation being reduced. Anion has to be oxidation. Okay, it's the opposite. So anion is based on concentration. Okay, it's very simple. OH minus will be the default negative ion to discharge. This is hydroxide ion. Okay, no matter what, you will always put hydroxide ion as the default ion to be discharged first. Okay, unless this is the only other way that to discharge an ion. Okay, is to discharge Cl minus, Br minus, and I minus. These are halides, group 7. Unless all these three, okay, either of these three, sorry, are present in high concentration. Okay, this will be discharged instead. Okay, otherwise, OH minus is the default anion to be discharged. Okay, other anions such as SO42 minus, NO3 minus, CO3 2 minus will not be discharged at all, because they are too complex, too big in some sense. Okay, let's just summarize. For example, if I have OH minus, I have a dilute, maybe say Cl minus. Okay, this is dilute. Okay, which one do I choose? I will choose OH minus. Okay, without a doubt, because OH minus is a default. What about the next one? OH minus, and I have say I minus, but it's concentrated. Okay, they will specifically say this in the exam question. Okay, which one do I choose? I will choose I minus. Okay, because it's concentrated. So this is the only way either Cl, Br, or I can be chosen. That is when they are in high concentration over OH minus. Okay, otherwise OH minus will always be the default way to choose an ion. Okay, that will be all for selective discharge rules.